Zeal Education Society, redefining excellence.
Hello, good morning to everyone. Myself, Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeal College of Engineering and Research, Pune. In a previous video lecture, we have learned the variable reluctance taper motor, its construction and principle of operation and applications. In this video lecture, we are going to learn the permanent magnet taper motor. Let us see its construction, the stator and rotor. The stator is made up of steel laminations and has a projecting poles and wound with P/2 number of phases. These phases are excited by DC source using the driver circuit, and it also uses the single stack laminations. Rotor is cylindrical in type and has made up of permanent magnets like ferrites. It has no winding, commutator and buses. So the no external source is required, DC source is required for the excitation. Now see the principle of operations. So what is the working? Now let us have the stator. Stator has a 4 projecting poles as shown in the figure A, and these projecting poles, 4 projecting poles, each pair of poles, one winding is provided. That means it has 2 windings A and B, by which the stator windings are excited by DC source using the driver circuit, and it has 2 cylindrical type of poles for the rotors which are permanently magnetized. Now here see the steps. The angle through which shaft rotates for every command signal received to the stator circuit is nothing but a step angle, and it is here the stator poles are 4 and rotor poles are 2. Just a minute. And here m equal to 2. So beta equal to ns minus nr into 360 divided by ns into nr, and that is equal to 90 degree, or beta equal to 360 degree divided by m into nr. M equal to 2 and nr is 2, you will get the step angle 90 degree. So the step angle for the permanent magnet taper motor is large as compared to the variable reluctance motor. Okay. Now here the pair of poles are excited by one winding, say A, and another pair of poles is excited by the winding B. So it has 2 phases and 2 windings are excited. Now here, when the way of exciting is on either sides, A plus, that means current flowing through the winding is IA plus, and according to the sense of current flowing, it produces the north pole and south pole. Look at the figure A. When current is passed through the point A, the direction of current is here clockwise, looking from this side. The direction of current is clockwise, so it generates the south pole here. Similarly, it creates, looking from this side, it generates the north pole here. So the permanent magnet rotor tries to align along the direction of axis. That is, they align with the stator polar axis and rotor polar axis. as shown. So at this situation, the stator polar axis and rotor polar axis, there is no angle generated, and therefore theta is 0. Okay. Now when the A plus is excited, then let us excite the B winding, that is pass the current B plus like this, B plus, and therefore the sense of current is like this. Looking from this side, it produces the north pole here and south pole here. So as the south pole is generated here, what happens? This south and south will repel. However, this north pole will attract to each other and it will align. See, here will be a stator polar axis like this and rotor polar axis. Again they coincides. However, this north pole, which was earlier, now the rotor rotates through an angle 90 degree, one step. Rotor rotates through an angle 90 degree, that is one step. Okay. Now if the A winding is excited from the A minus side, that is the current is IA minus from this side. So the poles produced accordingly, if you look from this direction, it produces the south pole here, that is the direction of current is looking from this side, it is clockwise, and if you look from this side, the direction of current is here anti-clockwise. So it produces the north pole. So this is the stator polar axis and stator polar axis. Now see what happens here when this is excited, and here the south pole is produced, this south will repel, however this north will attract. So the rotor will rotate through further 90 degree, and therefore the step angle becomes here, theta will become 90 degree. There is a half a rotation is produced. Okay. So in the similar way, if you excite from the B minus, that is current flowing is IB minus, as shown, IB minus. Now look at this sense of current from this side. Looking from this side, the direction of current flowing is anti-clockwise, so it generates the north pole here. And looking from this side, the direction of current flowing through this is clockwise, so it generates the south pole here. And what is happening here? See, here it is south pole, here it is north pole. So this south pole and south pole repel, however this north pole will attract. So in order to align the rotor poles along the stator polar axis, the rotor further rotate in a forward, means clockwise direction through 90 degree, thereby producing the 3 steps and theta equal to 270 degree. So once again, say up till now we have excited from A plus, B plus, then A minus, B minus. Once again, if we excite sequentially A plus, when A plus is excited, see here, it creates the south pole here. So what will happen? This north and this south will attract, and here it is it creates the south pole, so it creates the north pole here, so this will also attract, and the rotor will further rotate through 90 degree, thereby completing the 360 degree, which is not shown here. You can observe here it will be complete rotation of 360 degrees. So in this way it completes the one rotation in a clockwise direction by sequentially switching in the manner A plus, B plus, then A minus, B minus, and once again A plus. It completes one rotation and rotates in a clockwise direction. Okay. In order to rotate the motor in a counterclockwise direction, we have to change the sense. Of this one. Pay attention here. See here, direction of rotation. Just now I have discussed. Now see here, the A plus, then go for B minus, A minus, B plus, and once again A plus. The motor will rotate in a counterclockwise direction. Okay. So this has been just now explained. Now during this one rotation, this is known as one phase on mode. Means one phase is excited at a time. And the truth table is as shown in the figure. Table number 1. Pay attention here. The coil A or phase A and phase B. here the angle theta. When A plus is excited, the angle is 0. Then B plus is excited, the angle becomes 90 degree, that is the step angle. Then A minus, see here, minus symbol is shown here. A minus is excited, rotor further rotates through 90 degree and becomes 180 degree in a clockwise direction. Then excited by B minus, rotor will further rotate through 90 degree in a clockwise direction and the total angle is 270 degree. If you plus A plus, means current flowing is IA plus, it will rotate through further 90 degree and the total angle will become 360 equivalent to 0 degree. So in this way, on one phase mode, the one revolution we have completed, and we have also seen how to obtain the direction of rotation of a permanent magnet stepper motor while working on one phase on mode. But here it has been observed that the step angle is quite large, that is 90 degree. Now if we see, this is the two phase on mode, see here should be a correction little bit, two phase on mode. So in this case, truth table is shown here, the two phases are excited simultaneously. Here also the step angle is 90 degree. However, when the A and B are excited simultaneously, the rotor, both the windings has equal current, and the torque is produced because of both the windings, and its average torque is in midway between the 0 and full step. That is 0 and full step is 90 degree, midway is 45 degree, it is shown here 45 degree. Now further, if you A minus and B plus, the angle is one step 135 degree, then both A minus 225, then A plus B minus 315 degree, and both A plus and B plus 45 degree once again. Now if half stepping, if you combine the sequential operation of the one phase mode on and two phase mode on, you will get half steps. As shown in the table, to table 3. Now pay attention the sequence. Sequence is A plus, the angle is 0. Then A and B both are excited simultaneously, A plus B plus 45 degree, then B plus 90 degree, then A minus B plus 135 degree, then A minus 180 degree, then both A and B minus 225 degree, then the B minus 270 degree, A plus 315, A plus and B minus 315, then once again A plus 360 degree or a 0 degree. So in this way, the half stepping can also be obtained. Even similar to the variable reluctance motor, we can obtain the micro stepping also to get the lace angle. But what are the limitations for this? The limitations is, this thing already we have studied how to obtain the reverse the direction of rotations. Now here the limitations is this one. This rotor, these are the teeny motors, very small motors, and it is difficult to produce many number of poles, permanent poles, and therefore the step angle could be obtained 30 degree to 90 degree. However, the advantage of this permanent magnet stepper motor over a variable reluctance motor, it's as it has a permanent magnet rotors, no excitation is required, so power consumption is less. Then it produces higher detained torque. What is the detained torque? Detained torque is required even though the supply is off. The motor achieves the next step. Especially, I would like to give the example of the lift used in the commercial, in the societies, residential societies, or anywhere in the residential buildings. If the supply cut off and the lift is in between the say third floor and fifth floor, in between the floors, because of detained torque, it reaches to the next floor. That is, it will go to the fourth floor and stop there. Or when you are coming down, it will reach to the third floor and then stop there. Means it will not be in between, it will not hang in between the third floor and fourth floor. That we can say the example of the retained torque. And another thing is the permanent magnet motor has a more torque per weight ratio as compared to the variable reluctance motor. What are the applications of this permanent magnet stepper motor? This can be used for aeronautical applications, then the industrial applications, toys, manufacturing, then the control industries, process industries, and positioning controls, mills and printing, etc. We will stop here. Thank you very much.